So let's take a look at using this binomial model with Excel. So this video is going to go through the same calculations as I did with GeoGebra. So if you already know you're using GeoGebra, you can skip over this video because I'm just going to go through the exact same example. But if you have a preference for Excel, this is how you would go about those same problems. So the setup of our binomial probability distribution, it's going to be defined by a few pieces. So this is our definition up here. So to define the model, we write out capital X. So that's our random variable that we're working with. So we have X, and then that kind of squiggle line to say is defined by. And the model we're using is binomial. So we write out the word binomial to tell us our model. And then we start parentheses and we want two pieces of information. We want the value for n and the value for p. So the value for n is the number of trials and p is our probability of success. So all of that together defines our model. Again, with success and failure, it's not necessarily that positive or negative connotation that the English language has on them. Success is the idea of that it matches up what we're looking for versus failure, which is not what we're looking for. So you might come across an example. I think there's an example with like microchips or something like that, and that you're looking for microchips that are not working, and there's this 3% chance that a microchip does not work. So then what's the probability that in a batch of 10 microchips that 3 don't work? In that scenario, because we're looking for that does not work, that would be our success. So the idea that it's lining up. So 3% would be our probability of success because we're looking for things that are technically failing, but the idea of that they don't work. All right, so P is for our probability of success. Q is our probability of failure, which is just the complement of our probability of success, so 1 minus P. We use capital X as our random variable to describe the number of successes in n trials. Expected value and standard deviation we can calculate. So expected value, E of X, comes from taking n times P. Standard deviation, which would be sigma, or you may see it written as SD of X, is equal to the square root of n times P times Q, all under that square root. So in Microsoft Excel, what we're going to do is you'll be in one of the cells, and what you'll do is you'll type the equal sign. So equals will start a calculation for you, and then you're going to type in BINOM DIST, so binomial distribution. And then you start parentheses, and you're going to list 4 pieces that are separated by commas. So it goes X, comma, N, comma, P, comma, and then you have to choose between true or false. So let's go through those values. So X is the number of successes that we're looking for in trials. Then N is our number of trials. P is our probability of success. And then we choose true or false based on the setup of the question. So to start with, choosing false, that's going to find our exact probability. So if we're looking for P of X equals some number, so some exact number of successes, then we would type in false for that last piece. True is going to create a cumulative probability, so that's where it's adding up probabilities for us. The thing is with Excel, it can't guess which direction we want to add up in, because sometimes we're adding up the values less than or equal to, or we're adding up the values more than or equal to. So we'll have to get a little tricky here sometimes because Excel assumes we're finding less than or equal to. So I'm going to kind of describe it as this area to the left in a way, which that area description I'm using kind of comes up in that GeoGebra. It creates more of a visual with that graph of the kind of probabilities distributing. But it's the idea that if we list out all of our possible cases of like what we could have for x, we're finding less than or equal to. So to find more than or equal to, we'll need to use the complement rule. So we'll take 1 minus and then whatever we want to exclude. That wording might be really confusing there, but I promise I'll break it down in this example here and how we're typing it in to Excel and kind of how we know to when we use true or false, also when we use the complement and how we need to do that. All right, so we have our free thrower is still making 82% of her baskets. So that's our probability of success. So P is equal to 0.82. Assume each shot is independent of the last, so that probability is not changing. And then she's going to shoot 10 free throws. So that's our number of trials. So N is equal to 10. So if we wanted to write a definition for our model, how I would describe this is our variable X is defined by, so that's that little squiggle line. And then this is binomial because it's just success, failure, there's independence, so we're good to go here. So X is defined by binomial. And then I'm just going to list N and P, which would be 10, 0.82. So that defines our model right there. So what's the probability that she makes exactly 5 free throws? So what we're looking for here is P of X equals 5. So the probability that X is exactly equal to 5. So this is a case where we're going to use the false statement because I just want exactly some number. So what we're going to do is type this into Excel, and I'm going to go ahead and write out here what I'm going to be typing in. So we're going to go equals binomdist, so binomdist. And the first thing they want is the number of successes we're looking for, and we're looking for 5 successes. So I'm going to go 5, comma, and then N, our number of trials is 10, comma, P, our probability of success is 0.82, comma, and then because I want this exact value, I'm going to type in false. And close the parentheses and hit enter, and that should give us our probability. So let's go over to Excel and type this in. So equals binomdist, parentheses. So we're doing 5, comma, 10, comma, 0.82, comma, false. And we get out 0.017654. We're going to go ahead and round that to 4 decimal places. So that'll be a 0.0177. Now we just copy that probability down. And in terms of work we're done, we'll just make a sentence that there is a 1.77% chance she makes exactly 5 free throws. Five of the 10 free throws. All right. Okay, so there's our exactly scenario. Now let's look at what if it uses or in the question. So what's the probability that she makes 9 or 10 free throws? So if you remember from our probability section, when we have or, we are adding. We're adding probabilities together when we work with or. These are mutually exclusive. She can't make both just 9 and just 10 free throws. It's just one or the other. So what we're going to do is add the probabilities. So we're going to take the probability that X is equal to 9 plus the probability that X is equal to 10. So what we're going to do in Excel here is we're going to calculate 2 separate probabilities and then add those values together. So I'm going to type into Excel is equals binomdist, and let's see, 9 successes, 10 trials, 0.82 probability, and we want exactly equal to 9, so we're going to type in false. And then we're going to do the same thing, but for that value of X, so that first value, instead of writing 9, we'll write 10. So let's grab those probabilities. So equals binom dist, and I can use that previous formula I already typed in. I'm just going to switch the 5 to a 9, or you can write it completely new, but since we're using the same trials and probability, that can save a little time. So 0.3017, so that's our probability of exactly 9. And then add that together, and you can write down more decimal places there if you want to keep it even more exact, but 4 usually does the trick. And then I'm just going to change the 9 to a 10, and that's a 0.1374. So we add those two numbers together with a calculator, and that's a 0.4391. And then we would make a nice sentence that there is a 43.91% chance she makes 9 or 10 free throws. All right, what's the probability that she makes at most 2 free throws? So now we're getting into the realm of less than or equal to, more than or equal to, things like that. This wording here, this idea of at most 2, that's going to be our less than or equal to. So 2 is the very largest value that we're going to allow. So we're looking for the probability that our variable x is less than or equal to 2. What can be helpful here? Possibly. It is kind of frustrating. It's a lot of work, but it helps me kind of make sure I have my wording right. And if the number of trials is huge, then definitely don't do this. But it isn't too bad in this case. If I try to think of all the possibilities for x, so what's the possibilities for the number of free throws she could make? Well, she could make 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what we're saying is 2 is the most value. So if I highlight 2, that's our largest value, so anything lower is okay. So the 0 and 1 are okay too. And this is what I was kind of saying, like left-sided, of we're going to the left of the 2. And this is what the cumulative function of Excel automatically does. So what we're going to do is type into Excel equals binomial distribution. Our value for x, so the number of successes, is that largest value, that 2. So we're going to type in 2, and then 10 for the number of trials, 0.82 for our probability of success. And then because we want it to add up these probabilities of what I highlighted with 0, 1, and 2, we are going to write true, since it's cumulative. Okay, so let's go to Excel and type in equals binomial dist 2, 10, 0.82, true. And what's showing up here is 3.5, but then there's this E with a -5 there. That's scientific notation. That's the equivalent of, let me write this down. I'm just going to do 3.5. So 3.5 E -5 is the same thing as 3.5 times 10 to the -5. So that -5 exponent is telling you to move the decimal to the left 5 times. So we go 1, 2, 3, 4, 5. So what we're going to have here is 0.00035, which rounding that to 4 decimal places is pretty much 0. So what we would say for this is a 0% chance that she makes at most 2 free throws, which makes sense. If she has an 82% chance of making a free throw, she's very skilled. She's good. So if she's shooting 10 times to make it most 2, is going to be hard for her because she's so good. So kind of recognizing where we expect to land. I know we're not calculating expected value until later, but this idea of we do expect her to make around 8 of the free throws. So to be so low and far away from that expected value is going to have low probabilities. Okay, so what's the probability that she makes at least 7 free throws? Okay, so what we're going to do here, I'm going to go ahead and write out that distribution again. So those possibilities for x, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So making at least 7, so let me go ahead and highlight 7 there. 7's the least value, so we want that value and everything to the right. So this is going to be a right-sided calculation. So we want 7 and everything above. So we're looking for p of x more than or equal to 7. Now, like I was saying, this cumulative function within Excel only calculates to the left. So what we need to do is get a little creative with how we set up our function. So what I have here, and this is where I like kind of writing all of it out, is because what we can see is what we want to exclude. So we have highlighted 7, 8, 9, 10, and we're excluding 0 through 6. So what I can use is thinking about this part that's excluded, because all of that together, all of the probabilities together make 100%. So what I want to do is think of this probability of x being more than or equal to 7. That's the same thing as 1 minus this piece that we're excluding, these probabilities 0 through 6, which is the same as p of x less than or equal to 6. And thinking of it that way, now we can use Excel because Excel is working in terms of this less than or equal to. So for any functions that are working with more than or equal to, greater than or equal to, or at least, you'll be using this complement rule here. So 1 minus and then everything you want to exclude. And typically it's bumped down by 1 of whatever number you're looking at. So even though we're looking for 7 and above, what we're going to end up typing into Excel for this probability of x is less than or equal to 6, we're going to be using 6. So in Excel, we're going to have this 1 minus, and then binom dist, 6, and 10, and 0.82, and true, because we want those probabilities added up. We want that range from 0 to 6 in there. So what we can do is type it in all at once. So I'm going to go equals 1 minus, and then type in binom dist, 6, comma, 10, comma, 0.82, comma, true. Enter, and that's a 0.9117. So there is a 91.17% chance that she makes at least 7 free throws of the 10. All right, so we've kind of seen multiple cases here. Exactly equal to, less than or equal to, which we can just kind of work directly with. More than or equal to, we need to work with the complement of the probability that we're finding. And this next one, between two values. If you hear cringing in my voice, it's because this does get a little messy, but not impossible, especially if you kind of write this out. So I'm going to write out that 0 through 10 again. 5, 6, 7, 8, 9, 10. All right, so what's the probability that she makes between 6 and 8 free throws? So we're looking for the probability of 6 is less than or equal to x is less than or equal to 8. Okay, so between 6 and 8, and with these, they're inclusive, so we're including the 6 and 8. So the probability I'm looking for is I'm going to highlight 6, 7, 8 here. Okay, 2 ways to go about this. And I'm probably going to, I'm going to show you a difficult way, and that'll help when there's a lot of values. In this case, if we're looking for 6, 7, 8, I would just go the addition route, like find the probability of 6, add it with the probability of 7, add it with the probability of 8. That works fantastic. When that gets tedious is when, like, if we were looking between 2 and 9 free throws, that can get pretty tricky. but it's still correct. You can find all those probabilities, add them up together, and that's the correct answer. So if you like that route, go for it. I'm even kind of liking that route right now too before I explain this tricky way, but let's go for it. All right, so what we're going to use is a difference of probabilities here. So the idea that I want this 6, 7, 8 highlighted, what we can do is if we think of Excel kind of doing this thing of shading to the left, it's taking the probability of that value and everything less than. So if we did that with 8, that would include all values 0 through 8. So if we found this probability of x less than or equal to 8, that's going to take all probabilities from 0 to 8. So it's highlighting too much because we only want the 6, 7, 8. So we have part of our probability in there, but we have all this extra stuff that we want to exclude. So what we can do is, because if we see what we want to exclude there, so we want to stop between the 5 and 6 because I want to have that 6, 7, 8. I want to get rid of everything from 0 to 5. So that right there is a probability of less than or equal to 5. So what we can do is take this overall probability of less than or equal to 8 and then subtract the probability that x is less than or equal to 5. And those are both things we can plug into Excel, and it's finding that area to the left. So we're creating a difference there. So I'm going to have two functions to type in. We're going to have a binomial distribution for 8, 10.82 true, and then subtract that with the binomial distribution with 5, 10.82, and true. So let's type that in. Okay, I'm going to go equals binom dist 8, 10.82 true, and then close the parentheses, then subtract binom dist 5, comma, 10, comma, 0.82, comma, true. And that's a 0.5395. Now we're done. So for between, it can end up being the difference between two probabilities, kind of taking that probability of the largest and then subtracting the probability that you want to exclude, which is usually probably always one less than your smaller value. So because we were looking between 6 and 8, we took the probability of less than or equal to 8 minus, and then bumping 6 down to 5, probability of x less than or equal to 5. But again, you could do what we did in part B, that like making 9 or 10 and just adding the probabilities. This is the same thing as saying what's the probability she makes 6 or 7 or 8, and just adding those separate probabilities together. This is just good when you have a lot to add up. Okay, expected value and standard deviation. So expected value comes from n times p, so that's taking 10 times 0.82. So we can plug that in a calculator, and then it'll be 8.2. For standard deviation, we're taking the square root of n times p times q, so that'll be 10 times 0.82 times 0.18. And I'll show you how to type that into Excel. Can calculate that for you. If you go equals and then SQRT is for square root, and then you can do parentheses 10 times 0.82 times 0.18. Close parentheses, enter, and there's our 1.2149. 1.2149. Okay, so from here, we're going to go to practice. I separated this up with practice in GeoGebra versus practice in Excel because they operate pretty differently. So what you want to do is, if you're using Excel, you can skip over that practice video that's in GeoGebra, and there'll be a video specifically for that same practice sheet, but with Microsoft Excel.